Hello, Sarandon. So for today, I would like to ask you a few questions about specific heat capacity.
Hello, Joelyn. Be my pleasure to answer your questions. Let the other students learn from us, yeah? Thank you.
So let's get started. First, which one does have larger heat capacity? Metals or plastics?
Of course, metals, because as you can observe, that plastics will melt faster and earlier than metals. This describes that plastics needs lower heat energy to increase its temperature and reach its melting point.
Sarandon, how can we define specific heat capacity?
Specific heat capacity can be defined as the amount of thermal energy required to raise the temperature of a unit mass of a substance by 1 degree Celsius or 1 Kelvin.
Okay, sir. Then can you tell me what is the unit of specific heat capacity?
SI unit for specific heat capacity is Joule per kilogram degree Celsius.
So, sir, if the specific heat capacity of cooking oil is 2000 joule per kilogram degree Celsius, what does it mean by that, sir?
It means that we need 2000 joule of heat energy for every 1 kilogram of cooking oil to raise its temperature by 1 degree Celsius.
Okay, sir. And what about the specific heat capacity of water that is 4200 joule per kilogram degree Celsius? Does it have the same meaning as the cooking oil?
It's different. It means that we need 4200 joules of heat energy for every 1 kilogram of water to raise its temperature by 1 degree Celsius. So the difference is the amount of energy for every kilogram of mass and the increment temperature of 1 degree Celsius.
So which substance does have bigger specific heat capacity? Cooking oil or water?
Of course, water, because it has specific heat capacity of 4200 joule per kilogram degree Celsius, and oil has specific heat capacity of 2000 joule per kilogram degree Celsius.
So, sir, which substance between water and cooking oil will become hotter if both of them receive the same amount of heat, and we assume that their mass are just the same?
Definitely oil, because it has specific heat capacity of 2000 joule per kilogram degree Celsius. It means oil will need only 2000 joule of heat energy to raise its temperature by 1 degree Celsius for every 1 kilogram of its mass. For water, it has specific heat capacity of 4200 joule per kilogram degree Celsius. It means it will need 4200 joule of heat energy to raise its temperature by 1 degree Celsius for every 1 kilogram of its mass. So if water and oil receive the same amount of heat energy, oil will become hotter and it will increase its temperature faster because it has lower specific heat capacity.
Thus, Sir Anton, what is the conclusion from this data?
The conclusion is object or substance with larger specific heat capacity will show lower increment in temperature compared with object or substance with smaller specific heat capacity. It needs higher of heat energy to heat it up with the same amount of mass.
Okay, Sir Anton, so can you estimate how much heat needed to increase the temperature of 1 kilogram of oil by 2 degrees Celsius?
We know that specific heat capacity of oil is 2000 joule per kilogram degree Celsius. This means that oil will need 2000 joule of heat energy to raise its temperature by 1 degree Celsius for 1 kilogram of its mass. Now, if the mass is still 1 kilogram but the temperature increment is twice, that is 2 degrees Celsius, so the heat needed by the oil now equals to 2000 times 2. So the result is 4000 joule of heat energy, because the increment of temperature is twice now, although the mass is still the same, that is 1 kilogram.
So Sir Anton, which one does need more heat? Increasing temperature of 2 kilogram of water by 10 degrees Celsius, or increasing the temperature of 3 kilogram of oil by 5 degrees Celsius?
Let's count on it. We know that specific heat capacity of water is 4200 joule per kilogram degree Celsius. Hence, for every 1 kilogram of water, that would be needed 4200 joule of heat energy to raise its temperature by 1 degree Celsius. And now the condition is what would be the heat needed by the water if the mass is 2 kilogram and its temperature increment is 10 degrees Celsius. I got 4200 joule of heat energy times 2 kilogram times 10 degrees Celsius. The result is 84,000 joule of heat energy needed by the water to raise its temperature by 10 degrees Celsius. And now for oil. We know that the specific heat capacity of oil is 2000 joule per kilogram degree Celsius. That would be needed of 2000 joule of heat energy for 1 kilogram of oil to raise its temperature by 1 degree Celsius. Now the condition is what would be the heat needed by the oil if the mass became 3 kilogram and its temperature increment is 5 degrees Celsius. I can calculate that the heat needed by the oil now is 2000 joule of heat energy times 3 kilogram times 5 degrees Celsius. The result is 30,000 joules of heat energy needed by the oil. So the answer is, which one does need more heat energy? Of course, water, because the result is 84,000 joule, and oil is only 30,000 joule of heat energy.
Okay, sir. So lastly, what is the formula to calculate the heat needed?
The formula for calculating the heat needed by a substance or an object to raise its temperature of a unit mass of its object or substance is written as Q equals to M mass times C, the specific heat capacity, times T, delta T, the change in temperature. Yeah, so I can say it once again. Q equals to M times C times delta T. Yeah, Q stands for the heat needed, and then M stands for the mass of the substance or the object, and then C is the specific heat capacity of the substance or the object, and then delta T is the temperature increment of the object or the substance.
Okay, sir. Thank you for answering all of my questions. Thank you. That's all. Goodbye.